In this video, we're going to be solving the problem on capacitors. Okay, now on the board we're having a series of capacitors arranged in both series and parallel, and we're going to be attempting this problem. Now the question says, what is the equivalent capacitance between the points M and N in the circuits below? Okay, now here is the circuits. We're having a 6 microfarad, 6 microfarad, 12, 6, and a 9 microfarad connected across we're having some series of connection here, and we are asked to find the net or equivalent capacitance. That is, if this whole circuit were to form a single capacitor, what is going to be the capacitance? Okay, that is what we want to find out. Now, to do that, we are going to be considering both the series and the parallel connections for what we're having on the board right now. Okay, we're going to be considering the series and the parallel connections. Now, first things first, you might want to start from the place or the point that looks easier to treat. Okay, now in this case we're having a 12 microfarad and a 6 microfarad. You can see they are connected by the same line, and to get the net capacitance, we're going to make use of the formula or the method of solving capacitors in series. Now, if you don't know how to solve capacitors in series or you don't know the formula, you might as well want to check one of our videos on capacitors, still on our playlist. Okay, and it will help you understand how to solve for capacitors in series and in parallel, of which you can now come here to attempt this problem you're having on the board. Okay, now having a 6 microfarad and we're having a 12 microfarad. Now these two guys are in series, so I'm going to solve them as though they are in series. Okay, now I'm going to say the 12 and 6 microfarad capacitor are in series. Okay, so to solve these two guys that are in series, we're going to say the net capacitance, let's call it C1. Okay, 1 over C1, because they're in series, will be equal to 1 over 12 plus 1 over 6. Okay, that is how it is being done. And then we can now say 1 over C1 is equal to 1 over 12 plus 1 over 6. When you add these two guys, it gives you 1 plus 2, and that's 3 over 12, giving us C1 to equal 12 over 3. C1 becomes the reciprocal, that is 1 over C1. When you turn it upside down, it becomes C1 over 1, we say as C1. Okay, equals 22 upside down as well, that becomes 12 over 3 to give you 4 microfarad. Now, here's what we're going to get. Okay, now it doesn't just end there. We're going to carry that 4 microfarad and replace it with what we're having on this diagram. So if I replace it to what I'm having in this diagram, I'm going to have a new diagram like this. I'm just going to do a rough sketch. I'm going to have a new diagram like this. Okay, 6 microfarad, and over here we're having a 6 microfarad as well. Okay, and then something like this. We're having a 9 microfarad, and okay, and then we've solved for the capacitors we're having here. 12 and 6 combined to give you a 4 microfarad, so I'm going to have a 4 microfarad. Now what you might notice is that we also talked about capacitors in parallel in previous video. Okay, so what we noticed that 4, 6 and 6 microfarad capacitors, they are all in parallel, right? So since these three guys are all in parallel, so I'm going to consider these three guys. So I'll come here and then I'll say the 6 microfarad capacitor, okay, the 6 microfarad capacitor and the 4 microfarad capacitors, these are all in parallel, and to solve them in parallel, we're simply going to add them together. Okay, so for these three guys that are in parallel, C2, I'm going to call it C2. Okay, now it's going to be equal to the sum of each of them. So we have 6 plus 6 plus what do we have here, 4. Now we take the sum of these two, we get that's 12, 16. Okay, so you get 16 microfarad. Okay, that's the value you get for these ones that are in parallel. Okay, now by solving these three guys to give you 16 microfarad, we notice our new diagram now becomes a single capacitor that is representing these three. Okay, that is the equivalence of these three capacitors, so they are acting as one. So I'm going to have something like this. I'm going to have something like this. Is 16 microfarad, and of course we're left with one more connected to the 9 microfarad. Okay, connected to the 9 microfarad. Okay, Now what you notice is that so I left with two capacitors, a 16 microfarad and 9 microfarad capacitors. Okay, and these two guys are connected in series. Okay, there is a straight line wire connecting both of them, so they are connected in series. And to find the equivalent capacitance, which I'm going to call C3, since they are connected in series, remember 1 over the equivalent capacitance, so 1 over C3 is going to equal 1 over 16 plus 1 over 9. Okay, when you do the math, you're going to get C3 is equal to 16 times 9 divided by 16 plus 9. Okay, let's get that to our calculator. So we're going to have 16 times 9 divided by 16 plus 9. That is going to give us a value of 5.76 microfarad. Okay, do not forget each of them we're given in microfarad, so don't forget to include that in units. So that is how a problem like this is being tackled or solved. Okay, in our next video we'll be solving a different problem on capacitors. Okay, I advise you also watch that video to help you gain more understanding on capacitors. So do wait to click on the notification bell so that when that video is being uploaded, you'll be one of the first persons that gets notified about it. Stay tuned.